Good afternoon. Thank you for coming. I really do appreciate it. I don't know if some of you maybe had lunch plans or that sounded enticing, but I trust me, this hour is going to be better than any meal in San Francisco. I am thrilled to be here today. I have been in Intel 25 years, 10 of which I've been laser focused on the public cloud. For the last decade, I've worked with all the public cloud, anything as a service around the world, business to consumer, every geography. But for the last few years, this is my third time on this stage at Oracle OpenWorld because we have a deep partnership with Oracle. We have a decades-long partnership with Oracle on the on-premise infrastructure side, but in the cloud, we've been collaborating just as well, and we have a lot of things that over the last 3 years we've done, and today I get the opportunity to build on that story and share more about what we're doing. Now, this is how I get you to stay. At the end of the 45 minutes, we're going to be raffling off an Oculus Rift virtual reality headset and an Acer Predator Core i7-based gaming laptop. Anybody here interested? Okay, my 13-year-old asked for this for her birthday. I said no. She's asked for it for Christmas. I've said no, it's really expensive. So you want to stay for 45 minutes because one of you will get one. And if you don't want it, let me know because I need one for my daughter. So after my 10 years, I've kind of reflected back on the cloud. When I started, my first task was they said, can you just define the cloud for us? Because it really was a lot of hype. And we've come a long way over the last decade. But I can also say we're still at the beginning. We are at a new era of what the cloud can do for our businesses and our life. Cloud has created a massive disruption in how we consume and deliver resources. It's become a new way of architecting the data center for extreme scale and flexibility. This cloud thing is also connecting billions of devices, which is driving more and more people to connect to the internet, as well as new services and more data. And the cloud is the foundation for digital transformation. How we shop, how we receive medical treatment, how we work, how we consume media. None of this today could be possible without the economic benefits and the scale and performance that the cloud brings. So another question I get asked frequently is, especially, I don't know if you've been following 2018, but in the cloud market, it has been a huge growth year. Everybody in the world, the largest to the smallest, from the US to China, everybody has seen a massive boom in how the cloud is built out this year. So I get asked a lot, is it going to continue? Is there reasons, or are we just kind of hitting the law of large numbers and we're going to start to plateau? Well, let's look at some of the data. A lot of this public cloud is being driven by digital services. And we spend a lot of time talking about the public cloud or infrastructure as a service, PaaS and SaaS. But if you look at the top 3 infrastructure as a service providers in the world, only 13% of their revenue today is coming from public cloud. 70% of their revenue is coming from other digital services. And all of these digital services over the next 3 years are growing at about 20% year over year. So let's look at the other digital services. E-commerce. Only 18% of retail transactions today happen in an e-commerce or over the net. By the year 2021, that is going to grow to be a nearly $5 trillion market of goods and consumer services sold over the internet. And along with that comes digital advertising. It's also growing at about 15% to become a $400 billion industry by 2021. That's the online news, the media, the gaming, all of that is driving this growth. As well as digital media and video, which is the way I largely consume TV shows and movies these days, it's growing the fastest at 25% and will be a $120 billion industry by the year 2021. So that's a huge amount of growth, and all of that growth needs very compute-intensive infrastructure to fuel it. But we also have the public cloud growing it for both for business use and business transformation. It's also growing at 20%. It's going to be a $300 billion market over the next 3 years, and it's going to continue to grow. The explosion of digitally native organizations and artificial intelligence is just going to fuel this industry. Another thing that we've done at Intel is we do about every other year, we go out and we do a massive survey around the globe. And we survey CIOs, CTOs, data center infrastructure providers, heads of infrastructure, and we start tracking the trends. What workloads are moving? How are they building out their infrastructure? Where are their future priorities and investments going? And I'm going to share just a little bit of that data with you here today in the chart that you're seeing on the left. Enterprise adoption is growing strong in the cloud. The fastest growing is infrastructure as a service, but PaaS and SaaS, as well as managed private cloud, especially this year, is seeing large growth. And what we predict is by the year 2022, 50% of all compute cycles will be done in some form of cloud infrastructure. And this ties out really well with IDC's data that says by 2022, enterprises, 50% of them will be in a heavy multi-cloud environment, where multi-cloud means that they are working with greater than 10 different cloud providers or types of cloud in their infrastructure. So once again, this is going to grow and it's going to become more complex. So together we have to make it easier and more efficient to consume. And the last piece on this slide, I want to talk about the workloads. The early phases of the cloud was largely driven by the simple test and dev, native apps that were new development, collaboration apps. But we're seeing in the next 3 to 5 years, those kind of workloads are changing. Kind of all the easy, low-hanging fruit moved to the cloud first, and now we're in these middle ground applications that are the heavy workhorse applications of the environment. Business communications, more web infrastructure, enterprise resource planning, decision support, database, and AI are the fastest growing workloads moving into the public cloud over the next 3 years. So that's a little bit more difficult to manage in the public cloud than just test and dev. So we as companies, Intel and Oracle, are working together to create a better cloud environment that we can help accelerate businesses' transition to the cloud. And I want to talk about our approach. Hopefully you know of Intel. Hopefully you have at least one of our processors somewhere in your home. But we are so much more than a silicon company. That's where we started, but that's not where we are today. We are a data-centric company, and I'll explain what that means in just a minute. But we have a strategy that says to win and to provide value, you have to do more than just sell great silicon. Our approach is built on deep collaborations with the industry. We've done it in the past with the OEMs and the ISVs, and we're continuing to do it with the public cloud. We know that there's a diversity of requirements and workloads and services and scale needed. So we also know that if we invest our engineering resources alongside our partners like Oracle, we can create better services, more efficient services, and more value for you. And how we at Intel do that, with a focus on the service, we do start with our platform portfolio of silicon. We're the only silicon provider that delivers across compute, network, storage, memory, programmable FPGAs, as well as purpose-built and custom accelerators. We can do it all depending on the workload need. We also partner heavily on software engineering. Good hardware is only as good as the hardware that unlocks the value and takes advantage. So we put our engineers on site working on the software to make sure that everything is performance tuned and optimized to extract every bit of value out of that infrastructure. And third, we invest in large-scale enabling. And I'm going to end this presentation talking about a program where Intel and Oracle are investing millions to help move customers to the cloud. So I'm going to go deeper in all of these, and I want to talk about the data-centric era, or data center technology. You probably know Intel as a PC company. That was for decades what drove our business growth. But a few years ago, we transformed. We said the market and the industry and the workload needs need to be data-centered or data-centric. And we have changed everything we've done at Intel, from our investments, from our technology optimizations, to the type of technologies we deliver, to be focused on a data-centric environment from cloud to edge. And to do that in a data-centric environment, you need to just do a couple simple things. One, you need to be able to process everything. And one size doesn't fit all. So as I said, we have our CPU processors, but we also make purpose-built ASICs and FPGAs because you need to be able to compute many different things in this environment. We need to be able to move data faster to really take advantage of the large-scale data that's available and the compute power. And that's why we've developed our connectivity portfolio across Ethernet and OmniPath. And I'll give you a view into some new announcements we've just made about our 2019 product lineup. And of course, in the cloud, you have to store lots of data. Lots and lots of data, and you have to be able to do it cost-effectively. And that's why we've integrated across NAND to our new 3D cross-point-based technology called Optane that gives you multiple storage solutions for all of your different needs, size, capacities, and cost points. So as I mentioned, we're the technology partner that can do this. We have a lot of new announcements coming up, and if you'll give me just a second, I'm going to walk through a couple of them. Things that you should be looking for at the end of 2018 and into 2019 as you build or consume cloud services. The first is our next generation Intel Xeon processor. This processor is codenamed Cascade Lake, and it's going to go into production at the tail end of this year, which means it's going to be ramping across the ecosystem at the very beginning of 2019. Now, there are a lot of enhancements in this processor, higher frequencies, cache optimizations, delivering higher performance, but there's also new instructions, and this is really incredible for artificial intelligence, and I'll show you what that can do. Security is also a very hot topic in the industry. I don't know if any of you read a headline or were involved with Spectre or Meltdown, but it certainly changed the way we thought about security in 2018. Well, our next generation technology, Cascade Lake, has hardware mitigations built in to protect against Spectre and Meltdown variants, and that's going to come with this next generation platform. But the one I'm most excited about is our Intel Optane data center persistent memory, and whoever wins the Oculus Rift has to repeat that brand string back to me so that I know you were listening. Intel Optane data center persistent memory. We'll get t-shirts. But this technology is revolutionary, and we'll show you what it can do, because it is not just a memory technology or storage technology. It is a first of its kind, and I've been waiting for it for a decade, and it's finally here. So I want to go back to instructions, that instruction set that I mentioned that was coming for Cascade Lake. It's all about artificial intelligence. And artificial intelligence is an area that we have been reinventing on the Xeon processor. Today, the vast majority of machine learning and deep learning is run on the Xeon processor. And that's why we innovate directly into the CPU to speed deep learning training as well as performance. And we recently announced that we're adding this new instruction to this generation of technology, Cascade Lake, that we call Intel Deep Learning Boost. Now let's take a look at what Intel Deep Learning Boost means. So Deep Learning Boost extends the Intel AVX 512 with a new vector neural network instruction, or VNNI for short. That VNNI can handle intake convolutions with fewer instructions. Now, what does that mean for Cascade Lake? It means if you're using artificial intelligence or you're doing inference in your environment, you are going to be able to do it 11x faster with a Cascade Lake CPU than you can with our currently shipping Intel Xeon Scalable processors. So maybe you're not doing artificial intelligence today, but I guarantee you will be doing it soon. And these are the type of technologies, instruction sets that we can build in directly to the CPU that you can take advantage with up through the software stack in whatever application you're choosing. So I also want to switch now to the network, because this is probably an area, as I said, that you don't think of Intel as having a huge connectivity portfolio, but we do. Today, our Intel Ethernet 10 gigabit NICs have #1 market segment share across many different industries. And we also have OmniPath, which is a fabric that we ship into HPC. In August, we announced something new. We are expanding this portfolio with the emerging category of Smart NICs. Smart NICs combine our programmable FPGAs plus Ethernet to enable infrastructure co-processing. And this means that you can more efficiently execute security, storage, or network functions by using the programmable infrastructure that's on this Smart NIC. And that's going to give you better utilization of your infrastructure and better performance efficiency and better cost of your networking environment. So look for those in 2019. But just like I mentioned, our Intel Optane technology is a revolutionary new technology. We've been also working for years on silicon photonics. As the industry moves towards 100 gig networking and beyond, efficient connectivity is critical. And I'm talking rack to rack, data center to data center, and within the rack. The cost of that connectivity and the speed and latency of that connectivity are critical. So we've created a silicon photonic product, but ours is different. We've been able to integrate that laser directly into the silicon. And that means over time with our silicon photonics roadmap, we will deliver not only the lowest dollar per bit, but the highest bandwidth density and lowest power per bit in connectivity. So once again, it's about creating a broad range of technologies and portfolios that ensures you can do the compute and the processing and the networking and moving of data. And now we're going to talk about the storage. So we need to store more, and I am really excited about this. Launching, as I said, with Cascade Lake at the end of this year, Intel Optane Data Center Persistent Memory, a first of its kind. This is going to disrupt the memory and storage hierarchy and tiering environment in servers today. For decades, we've considered them two very different tiers, memory and storage. But with persistent technology, we are able to finally bridge that gap. So we're bringing native persistence and high-performance storage directly up to the working data level for direct load and store actions and instructions. And there's also something really cool about this technology. We will have, or we have today, we are shipping today, 512 gig memory modules. That is the largest capacity memory module in the industry, which is great. You'll hear about in just a second for things like in-memory database where you need large memory capacity. So we're bringing immense capacity up to the memory bus, and people have been waiting for this. This has been really fun for me to see. I've seen people get excited about our technology. I've seen some of my customers not so excited about our technology, but this is one where every single one has demanding they want more samples, more support. They want to launch, and they want to get this technology out into the market because it's a game changer. And to show you what that means, I'd like to invite on stage Ananth Raghavan, who's the Vice President of the Oracle TimesTen in-memory database, and Mitsumi Kogawa to come show you about some of the new use cases you can do with Apache Pass. Thank you.
Thank you, Raji. Good afternoon, everyone. I'm Ananth, and this is Matsumi, one of the lead developers in TimesTen. He and I are going to show you a fantastic live demo showing the benefits of Intel Optane data center persistent memory technology. I'll refer to this from now on as Intel persistent memory. We will do this using a prototype of TimesTen that has been modified to use Intel persistent memory. Let me first introduce you to TimesTen for those of you who are not aware. The Oracle TimesTen in-memory database has been around for more than 20 years and has been used in mission-critical applications around the world. If you have a cell phone, for example, the chances are that you have used TimesTen without knowing it. TimesTen is a SQL-based relational database and has all the standard properties expected of a relational database. It was designed from the beginning as an in-memory database, meaning that at runtime, we load the entire database into DRAM before starting to use it. Despite that, TimesTen databases are persistent. If you turn the power off, the data in the database is preserved. We do this by storing a copy of the database and the transaction logs in a file system on disk or flash. Because TimesTen is an in-memory database, it is amazingly fast. It provides response time measured in the millionths of a second. Finally, TimesTen databases are highly available via replication and can provide elastic scalability across many machines in a cluster. Now that you know what TimesTen is, we'll show you two live demos. These demos use a prototype of TimesTen that stores the database in Intel persistent memory instead of DRAM. The first demo illustrates the ability of Intel persistent memory to speed up database startup time. Now, before an in-memory database can be used, the entire database must be loaded into flash or DRAM. For a large in-memory database, this can take a long time. Naturally, customers that use in-memory databases don't want their users to have to wait. So they replicate their databases to another system, allowing them to fail over to that database while one recovers. But what if database recovery was instantaneous? Well, with Intel persistent memory, it is. By storing the database in Intel persistent memory, we don't need to load the database from disk or flash. The copy in memory is persistent, hence no need to load. Can we switch to the demo, please? Now, let's see how this works. We have two GUIs here, each managing a different TimesTen database. The one on the left is today's product, which stores the database on flash and loads into DRAM at startup time. The one on the right is a prototype, which stores the database in Intel persistent memory. Let's start up the database on the left. Since this is a large database, it will take about 13 minutes to load. We won't wait for it to load. Now, let's start up the database on the right, which is using persistent memory. This database is actually 3 terabytes in size, and look, it loaded in 0.4 seconds, way less than a second. As you can see, compared to the 13 minutes for DRAM, we were able to start up the database in about a half a second or less on Intel persistent memory. That sort of performance will allow our customers to design really interesting capabilities in the future. So to summarize, it took over 10 minutes to load a 1.35 terabyte database in DRAM and less than a second to load a 2.7 terabyte database on Intel persistent memory. So we see that persistent memory allows us to speed up database startup time. But what about when the database is running? Relational databases support transactions. Transactions allow applications to make multiple changes to data all in one operation. So we can subtract money from my bank balance and transfer it to yours in one operation. The money is never subtracted from mine, but never transferred into yours. Transactions are critical in databases. Transactions also have to be made durable, meaning that the database will remember them even when something fails or crashes. TimesTen can do this in a number of ways, the two most important being by copying the transaction to a standby database or by writing transaction log records to persistent storage such as disk or flash. Today, we'll focus on the method that writes logs. Writing transactions logs to flash can be a bottleneck. But suppose we put the database in Intel persistent memory. Since it is persistent, we wouldn't need to write the transaction logs to flash. Would that speed things up? Let's see. Matsumi, can you please start up the workloads? On the left, you see a TimesTen database stored in DRAM, which is writing transaction logs to flash. On the right, you see a prototype of a TimesTen database stored in Intel persistent memory. It is not writing the transaction logs to flash, only to memory. And since the memory is already persistent, there is no need to. As you can see here, there's a huge performance benefit to using Intel persistent memory versus flash. And we still guarantee persistence, transaction durability. The throughput while running on DRAM is about 174,000 transactions per second. The same workload running on Intel persistent memory, the throughput is about approximately 1.1 million transactions per second. That's about a 6.5 times improvement in throughput. Rather than use 2 servers and copy all transactions to a standby database, using Intel persistent memory, something got stuck. One can achieve amazing throughput, availability, and response time while running only one TimesTen server. This reduces complexity and cost while still maintaining performance, availability, and response time. To summarize, we can achieve about 1.16 million transactions throughput and a 6.5 times improvement over DRAM. We are really excited about persistent memory and hope to support it in TimesTen very soon. If you would like to know more about TimesTen, we have a hands-on lab later today and another one tomorrow. We have a TimesTen session tomorrow in Moscone West Room 3001 at 11:15. And we're also available in our demo booth in Moscone South. I'd like to conclude by thanking both the Intel team and my team who worked really hard to make this demo happen. And I'd like to welcome Regine back to the stage. Thank you all.
Thank you. Thank you. Okay, see how exciting that is? Anand couldn't even speak at the end. So excited. And actually, I have seen so many server demos in the last couple decades, and they're mostly like watching paint dry. I mean, that was pretty cool. I mean, that is real. And these are things that are going to be moving into data centers pretty soon and really changing the way infrastructure is utilized and the use cases that can be run on it. So I want to go to the second part of our strategy. I mentioned that while the breadth of our data-centric portfolio is the foundation, the key to unlocking that value comes in the software. Software is also where we create and develop new applications and services. So today, I have over 200 engineers that work directly hands-on with cloud service providers. These are hardware and software engineers. Today in 2018, they've already done about 150 different projects. And they go work side by side with our partners to optimize the code, whether that's infrastructure modernization, performance and tuning, workload tailoring, or even developing and creating brand new services. These engineers go side by side with our partners and do real work. And these engineers also work side by side with Oracle to increase the value and differentiation in the services. So we ask these engineers to go out and try to push the boundaries of what can be done, extract every ounce of performance and every ounce of efficiency out of that software running on the hardware. Because we know, especially at scale, every ounce of performance and every ounce of power can count. So one example of our work is the Oracle database in-memory option. And this implements leading-edge columnar data processing to accelerate data analysis in orders of magnitude, increasing the number of data values analyzed from millions to billions. Answers that used to take minutes are now instantly available, and applications that just couldn't be developed before now can. And we partner at each and every level of the stack to get that type of performance improvement out of the offerings we provide. Another example where our engineers work side by side is called Project Apollo. This is a joint engineering lab where our engineers can come together and they can work on cloud workloads in a scale-out data center environment. Through this type of work and understanding the workloads and understanding what's critical in running the performance and this level of infrastructure, we can do things like create custom CPUs for Oracle's workloads and Oracle's services that deliver a premium performance experience, as well as not just optimizing around our CPUs, we can optimize around our storage and network technologies as well. Now, I can talk a lot about what we're doing, but I think it's more interesting to hear a real example of how it's being put into place. Hertz Corporation. I'm sure every one of you at some time has been in a Hertz car. Did you also know that Hertz manages the dollar and owns the dollar in Thrifty brands, which makes them the largest vehicle and equipment rental company in the world, $9 billion in revenue, over 10,000 locations globally. They're striving to be a more service-oriented company, and they're going through a cloud-first business intelligence transformation for their company. And to do that, they said, well, we want a fully managed data warehouse in the cloud. Now, why would you do that? Because you can reduce the number of people administering and interacting with the database. You have more flexibility to scale up and down and get the capacity you need when you're in the cloud. You're enabling your employees to spend less time on administrative database tasks and more time on business analytics and insights to create customer value and new revenue. And it also enables the scale and speed and agility that Hertz needs to deliver information real time out to their field around the world. So it was a journey for Hertz. They needed to move faster, and they needed a more flexible developer environment to start on. So they had already migrated from Oracle Business Intelligence to the Oracle Analytics Cloud. But now they're moving from the Oracle Cloud to the autonomous data warehousing service for even faster analytics. It used to take them 1 to 2 weeks to requisition a new system. It now takes 1 or 2 days. And that's helping them drive this transformation. They chose Oracle because they needed a company that they trusted, who was fast and can scale and easy to use. And they also chose them, I believe, because they know Oracle runs on the Intel architecture and they're going to get the best value for their money when cloud services run on Intel. So now the Oracle Autonomous database does the patching, which saves those database administrators time, and those database administrators get to focus less on the mundane tasks and more on providing business value. And when they do that, the customer experience is better, and that's good news for us because HERS can pass along that value in a better customer experience and cost savings for its customers. Now, the third part of our strategy is about accelerating the journey to cloud. And to do this, you really have to understand what business transformation looks like. It's very complicated. So what we do is I'd like to welcome to stage James Stanbridge. James is the Oracle Infrastructure as a Service Product Management Vice President for EMEA and JAPAC. And he's going to come talk about the next generation technologies for Oracle Cloud Infrastructure. James. Thank you very much.
Hi, Reggie.
Thank you for coming all this way. We're so excited to have you share your story, Oracle Cloud Infrastructure. Tell me more about your strategy and products.
Well, as you've just discussed, our cloud is helping customers transform their operations. And Oracle's been helping customers manage critical data for decades, from moving data without having to change any of their applications to building brand new applications. Oracle Cloud focus is on helping customers move their mission-critical data to the cloud.
So how do you do that? Migration is very complex. How do you help those customers migrate?
Yeah, so we've designed Oracle Cloud Infrastructure to provide really predictable high performance, tremendous economics, and flexibility to help customers today and tomorrow. And of course, Intel's technology plays a critical role in achieving all of that.
Good.
I'll give you an example. Our bare metal compute leverages the Intel XEON Platinum processors. This supports the migration of entire application stacks without any re-architecture. Wow. Not only that, at the same time, it offers up to 30% performance improvement for Kubernetes workloads, as an example.
Yes, which is huge.
Right. So we enable global enterprises like Allianz, for example, to run complex enterprise stacks for business intelligence, data warehousing, without changing any of their underlying applications. So Allianz were running Exadata on-premise, and now they run Exadata leveraging the Exadata cloud services. And on that exact same infrastructure, we're enabling born-in-the-cloud type companies, such as Virtual Artifacts. Now, Virtual Artifacts have built an AI-driven social network. Now, that's real flexibility.
Fantastic.
Yeah. And look, it may seem surprising, but all of this is possible because we built the right fundamentals. So fantastic price performance. And it's often the case that better performance and predictability can be drawn from the cloud than dedicated on-premise hardware in many, many cases. And all of this, my favorite bit, is that it's infrastructure as code or programmable infrastructure. The dream really is a reality now in Oracle Cloud.
Okay, so that's great. So you're reducing the barriers to entry and making it easier to move. What's coming for your next generation infrastructure? Do you have some new announcements?
Yeah, so you know, if you saw Larry yesterday, we've had a lot of announcements around Oracle Cloud Infrastructure. It includes really great core-to-edge security capabilities, new partner ecosystem enablers, and a continued commitment and plan to expand our data center regions globally. And we're working with Intel on some really exciting new computing capabilities. We'll be ready to unveil those next month at the Supercomputing Show. Yeah. And it's just been so exciting as we've grown our cloud business together with Intel and continue to offer really great performance at terrific value, especially as performance requirements continue to increase.
Wow, that's great. You know, thank you. As I said, our companies have been working together for decades. We have delivered scalable, secure, enterprise-class solutions to the market. And that longstanding history of joint innovation innovation, and collaboration now extends forward to the cloud, and I look forward to continuing our work together.
Absolutely.
Thank you.
Thank you, Regine.
Thank you. So if you're interested in these technologies and services and capabilities, and you want to be like Hertz or other companies that are taking advantage for real business insights and transformation, I want to share more about a program that we have to help you do that. We have a program called the Cloud Ignition Program. It is joint between Intel and Oracle. And this program will pay for your pre-sales proof of concepts and migration of services so that you can see firsthand how easy and the value you get from moving your workloads to Oracle Cloud. And you can do many different use cases. You can move new or existing workloads. You can upgrade your on-premise infrastructure and replace older Oracle hardware. Or you can move from other architectures onto the Intel architecture. All of that can be done with this program. We launched it in 2017. We've had 170 customers take advantage of it, and we are extending it through the end of the year. So if you'd like to be a part of this program, please do reach out to your Oracle representative before the end of the year, and we'll get you involved. So I'm going to wrap up here. The things I want you to walk away from, and I hope you heard from me today, is that Intel and Oracle strive more to be not just a vendor, but a technology partner. And we do that through our deep collaboration and joint innovation, but we believe that that brings better products and better value to our customers. And we're investing. We know this market is ripe for growth. We know that when cloud grows, everybody wins. And so we are investing millions of dollars to help make your journey and your migration to the public cloud easier and better with Oracle services on Intel architecture.